Hello, welcome, and thanks for joining us today. My name is Eric Dame. I am a Senior Solutions Architect with Amazon Web Services. Today I'll be joined by Eddie Mayer, who is the Director of Cloud Platforms at Hilton. Today we're going to be talking about transforming Hilton's reservation system with Amazon Aurora. And as the name suggests, this is about their journey, but also we're going to share some details about things like best practices, lessons learned, and those sorts of things. A quick hit on the agenda. So today we'll be talking about. I'll let Eddie introduce himself and talk about Hilton. We'll go over some of the again the journey of Hilton and their journey to AWS, as well as we'll talk about things like testing, designing architecturally, and then at the end, Eddie will speak about some of the future plans that they have. So with that, one thing I'll mention as well. So while this talk is really meant to be to kind of showcase what Hilton sort of did this transformation, there would be times where I'll talk about other specifics that I think are important. So I'll talk about them more generally and just things that are best practices, right, that I think is worth sharing. So Eddie, why don't you take it from here?
Thank you, Eric. Hi, everyone, and thank you for tuning into this session. As Eric said, my name is Eddie Mayer, and I'm Director of Cloud Platforms at Hilton. Before Eric and I go into the nuts and bolts of talking about Aurora and moving the reservation platform to AWS, I wanted to provide some information about the company I work for at Hilton. So, if you did not know, Hilton celebrated its 101st birthday today. On the presentation, when Eric and I put this together, it was about 6,200 properties. At this time, we have about 6,300 properties now, almost 1 million rooms in over 118 countries. As you can see by the numbers, there is quite a far-reaching impact for Hilton moving the reservation system to AWS. So with every journey, there's a beginning. So for the first part of this discussion, we're going to rewind to about 4 years ago. The first part of this project was to work on migrating Hilton's availability engines to AWS, a core component of our reservation system. Availability engines are used by customers and third parties to find out what rooms are available in any of the properties worldwide. This also led to one of our first engagements working with AWS ProServe to work on architecting and building out the reservation system. The Hilton team and the AWS team met to start discussing the target state of the overall architecture, along with what AWS components were needed for the availability engines. AWS Aurora was definitely the choice for this first phase. MySQL was the choice for this work based on several functions. We had the read-write replica architecture, which is common with Aurora, and the self-healing capabilities that Aurora has today. As the Hilton team started to discuss future phases of the project, it quickly became apparent that while Aurora would be used for future iterations, we would need to change MySQL to Postgres by the time the project completed. Throughout this project, optimizations took a turn. Whether it was availability zone placement, custom endpoint usage, or instance type updates, all were done very quickly with AWS. Turning it over to Eric now just to talk about some database engines.
Yeah, so thanks, Eddie. One of the things that we wanted to call out and discuss is the different database engine types, right? And so in this case, we're going from a source database engine to a PostgreSQL database engine, but you might be going from a like-to-like, or even just, could be really any sort of database engine out there to something like Postgres or other, right? And so one of those things to keep in mind, or some of the things to keep in mind, are sort of highlighted here on the screen. But we're kind of going to focus on the two ones on to my right at least, and those are indexes as well as data types, right? And really for Hilton, these were two key areas that we wanted to identify, but also explore and really keep in mind those changes, right? So take indexes for example. Pretty much any database that I know of, when you create an index, by default that's a B tree index, right? Which is fine and typically runs or works well for most workloads. But keep understanding what indexes are available to you. In this case, it's going to be Postgres. So things like hash, right? Maybe you want to create a hash index, and you have a use case that fits that. Knowing, I guess, at least knowing that that's a capability that you can do is great. And then B, obviously, during this process, we wanted to make sure that we're planning up front, right? We're not going to have these issues down the line, or it's not going to be something that we've overlooked in the beginning. Better to know now than 2-3 months down the line, obviously. And the other part is data types, right? So this is a little more, I guess, nuanced depending on the database engine you choose. So again, we're talking about Postgres here, but knowing what data types may or may not transfer over to that engine that you're migrating from, right? Eddie will talk a little bit about this later on, but we do have a schema or an AWS schema conversion tool that helps you identify those data types and then what may need to be changed, right, for the destination. So again, Eddie will talk about that a bit in the future, but just some things we wanted to sort of highlight and bring to attention. So Eddie, with that, back to you.
Thanks, Eric. At this point in the migration, the availability engines were humming along, and the Hilton team began planning for the final part of the project, migrating the reservation capabilities to AWS. As you can imagine, a lot of planning went into this phase. While we weren't adding business capabilities, we were moving and changing the entire underlying platform from the application tier all the way down to the database tier. Considerations needed to be met for recovery point and recovery time objectives, preserving our target transaction rates, and ensuring that data replication would be in place until the cutover events occurred. We worked with AWS as the migration date got closer to ensure we had the best target implementation in place, and that the hardware quantities we expected to have cut overnight were available and pre-warmed to accept traffic. To accomplish this, my team and I worked with Eric and the AWS's technical account management team to complete the IEM process. The infrastructure event management process allowed the Hilton team to point out what the final infrastructure was and to make any finishing touches working with AWS. We would be used during cutover along with the pertinent details for traffic and thresholds. The AWS TAM team went through the documentation with us to ensure that AWS would have the support teams on standby as needed, and that the Hilton team was as ready as they were going to be. Before I go too much further into the migration, I want to talk through one of the tools that was used throughout the project, AWS's schema conversion tool. Part of the overall data migration process involved creating new schemas in the target Aurora Postgres database as part of each initial environment build. While this tool created a majority of the tables needed for the schema, there were some parts that were still manual. This part of the whole process, though, saved a lot of manual time by the DBA team. Eric is now going to walk through some of the Aurora Postgres testing processes.
All right. So as Eddie mentioned, a big part of this whole endeavor or transformation, if you will, was about testing, right? So we did spend a lot of time up front. Eddie and team spent a lot of time testing various components of the system, as well as the application itself. And so one of the things we often talk about AWS with customers is testing with your own application or your own workload, right? So things like benchmarks are great, and they're a great place to start from. But once you start testing with your real application, you're going to understand and be able to troubleshoot or fix things that may arise as you kind of move up to production, right? And so we definitely recommend testing, using your sort of real workload against this AWS infrastructure to really get a good sense of how your application is going to perform and doing your testing. The other thing that we thought was important to call out is something that Eddie again we'll talk about in a couple slides here, but using infrastructure as code, right? As I talked about these different testing components, or as you sort of iterate through your infrastructure, really codifying that is important, because then you can move that through one environment to the next, right? And so, for instance, with the great thing about AWS, obviously, is that you can spin up resources, spin them down and not have to worry about basically move on, right? So, for example, doing some testing in dev or a low environment, and then iterating through the results, codifying those, if you will, and then moving those to production eventually was kind of the path here. And then the last thing I think is important and something that is a bit technical, but also a bit I guess less technical is lessons sharing lessons learned, right? And so that's internally with the team. That could be things like informally sharing with your company, your internal to your teams. It could be chats, some sort of corporate chat you might be utilizing, as well as things like wikis, which are big for a lot of companies. But making sure you share lessons learned, whether they're big, small, or little, whatever it is, whether technical or not, is important, because then you're iterating upon that, and um, you're hopefully reducing pain for the next or engineering pain for the next project or process to come down the line. So, I spoke about testing for failure, or excuse me, about testing. So that kind of goes with application testing. But another thing you want to do is sort of test for what happens when things fail, right? And so, this example on the screen is showing how we're using a SQL injection, basically library or query, and this is relevant or specific to Aurora PostgreSQL. And this is showing just basically knocking down or taking out a read replica, and that way you can sort of test that in your environment, right, and see what happens to your application. And this is something that we didn't actually use this specifically with Hilton, but I think it's one of those things, as I mentioned before, that's worth calling out. There are a variety of other queries or fault injection queries you can use if you follow that link. One of the things that that I think is important is simulating things like disk congestion, right? And so I was sort of talking to a colleague and saying how back in my previous roles at other companies, pulling cables and pulling power cables, and even removing disks from storage arrays to see what would happen, right? And so that was sort of our version of testing for resiliency. But now you can do those things again through these sort of programmatic measures. And I think testing for disk congestion is really important, but also it's one of those things that's really harder to test for, and it kind of gives you the ability to do so using this library. So specifically for Hilton, some of the things they also did, right, to even build upon that and improve that sort of resiliency, was testing things what I would call sort of at the infrastructure level, right? So so removing security groups, for example, or deleting custom endpoints or other components or resources within AWS to see what happens, right? And then using that as a learning or a test to understand what happens, and then iterate from there. In this next slide, just one of the things that goes hand in hand or along with testing is obviously monitoring, right? So you want to make sure that when you're doing your testing, you're getting visibility into what's happening, right? So if you do purposefully remove a resource or change a configuration, you're going to use a monitoring tool of some sort to see what happens. And one of the things that I thought was worth calling out was the performance insights, right? And that's a tool that you can use within Aurora Postgres and some of the other RDS engines. But this gives you insight into your queries that you're going to run. I know this is something we used for the lower environments, at least, and things like diagnosing long-running queries or CPU memory, those sorts of things, which gives you a nice kind of dashboard to look at and be able to, frankly, troubleshoot as needed. The other thing, though, is that you really want to use alerting as well, right? So I know there's various alerts that were set up for this around different components to make things like if the system hits a certain threshold, you want to alert on that, and then do something about it, right? I think it's also important to kind of take that and think about your business itself, right? The application, what is it doing, and then alert upon issues or thresholds that are breached based on those issues, right? So, for instance, if you normally do X amount of transactions a day, and you see you're doing, much lower than that or much higher than that, is that indicative of a different issue or another issue they need to look into, right? So again, alerting upon not only just the things like CPU memory, but also things like higher level, I guess, business sort of functions or KPIs, as some people call them, key performance indicators, to understand, again, if there's um, true issues that are going on that maybe aren't necessarily um, uh, directly a cause of other issues or other sort of component type issues. And then the other thing I did want to call out, and wasn't it was fairly new, so it wasn't necessarily available to us at the time, but it was akin to this monitoring or performance insights, or I should say, it's a feature of performance insights, and this is SQL statistics for queries, right? So um, if you have a query that is taking a long time, and basically diagnosing queries, why that's taking such long, how many rows are being returned, those sorts of SQL statistics are now available in Performance Insights. So yet another way for you to troubleshoot and dig into your application. All right, with that, I will hand it back to Eddie to talk about your deployment.
So continuing along with what Eric was saying, as we tested the final system, we wanted to make sure we truly had a cloud application running for the reservation system. What this meant to us is that we would continue using the tenets that we had applied to other cloud projects in our ecosystem. For starters, just like Eric was saying, we wanted to be proactive. So we would set up alerts and monitors that would let the app teams and the operation teams know if thresholds were being met. Not only just the warning kind, but the alerting kind as well, just to make sure that we would be as proactive as we can, because at the end of the day, we all want to find out about anything that goes bump before our customers do. The other portion of this is resiliency. One of the main reasons we looked at Aurora was the resiliency that is baked into the component itself. We want to make sure that databases are always available. And to do that, we took several steps. We made sure that the availability zones for the databases were distributed as much as we could, similarly from the region aspect. To make sure that the databases were tuned as properly as we could, the database team and AWS made sure that everything was tuned and kept for posterity using parameter groups. And these parameter groups were put in code, so to make sure we had consistent deployments across all the environments. Some of these settings include vacuum settings and log levels, along with other performance tuning options, which were specific to our app. The other portion is you prepare for the worst, hope for the best, and part of that was some of the settings that we set for replica promotion. We wanted to set up very specific rules for if a writer failed, that specific read replicas would take the place of that writer instance that failed. And we worked with AWS to understand those parameters, and we tested those out, I would say very helpfully, just to make sure that everything was in place in the event of a failure. For part of the overall configuration is once we had the settings in place that we wanted, we tested, and then because we wanted to, we tested some more. A lot of this was just determining how the application would perform, how the infrastructure would perform, and just to make sure what the recovery would look like. And the majority of that to make sure it was as automated and as automatic as possible. Some of those features were what Eric was talking about earlier in some of the testing scenarios. We took some availability zones out of the equation. We took some security groups. We changed them up a little bit just to see what the traffic patterns would change to. We would take some read replicas out. We would change the writer instance to see where that would be. We overall just redirect traffic. I mean, essentially the equivalent of pushing buttons and changing wires just to see what it would look like and to make sure that the infrastructure was as resilient as it possibly could be. One take home that we had from all of this is we want to be the epitome of what you would call the lazy developer. You want to have everything in code and you want to be able to replay it without having to do much work. And we were able to accomplish that by automating through code. Whether it was setting up the database clusters, whether it was database parameter groups, anything of that nature that we could put in code to reproduce across environments, that's something that we took to heart and we put in place. One of these capabilities that we took to heart very well is snapshots. We worked the database team and the cloud operations team, tested through several iterations of Aurora's backup and restore functionality, like you see on the screen right now. We tested the snapshots in several different scenarios, including load tests, just to ensure that the vital functions wouldn't impact any customer experience. One takeaway during the snapshot was that certain RPO times weren't being met within cross-regional copies. So with that in mind, we tried a few more tests. We engaged Eric and his team to find a solution that satisfied our RPOs with Aurora Postgres. And the solution that we ended up using involved Lambda. So what we ended up doing, as you can see on the screen here, we use a CloudWatch trigger to engage a Lambda event, and that would very politely ask the Aurora instance to kick off a snapshot and send it to a specified region. What this custom work ended up doing was making sure that we created a snapshot with our explicit SLAs, and it was able to continue us with the migration process. So I would be remiss if I did not talk about infrastructure as code. So as Eric was talking about earlier, infrastructure as code for databases is just as important, if not more, than container hosts or standalone servers. The code isn't just for defining database clusters, but parameter groups as well. The lesson learned is that the stored code can be used across environments. If we have to create a new setup for consistent configurations and deployments, we have it in the code. If there's a failure and we need to push something back, we have it in the code. You might see a trend here. A few lesson learned we saw with parameter groups was that by changing certain parameter groups, it would restart the database cluster automatically. And it was all good in our test systems. We made a note of these. I highly recommend you guys doing that too. So the culmination of everything that Eric and I have talked about led up to the migration weekend, or shall I say weekends. The Hilton team set aside 2 weekends to migrate the entire reservation platform to Amazon. The team did many migration drills to plan for smooth transitions weekends along with AWS. By the time it got to the migration events themselves, the teams were ready. Due to the pandemic, all of the teams were performing the tasks from remote locations. No one was in a central location. Everything was coordinated over web conferences and phone. All the work and planning reaped many successful dividends. There was zero customer impact across the globe and zero data loss for any of the cutover events. In just 2 weeks, the collective team migrated the entire reservation platform to AWS. After the migration, we have continuously monitored the environment along with AWS for ways to improve as opportunities to present themselves. Eric, do you want to present some of those opportunities?
Yeah, absolutely. Thanks. So, as Eddie was mentioning, there were some things that came out of really a culmination of our conversations, deep dives, reviews, etc. And some of those, not all of them, but some of those are presented here. Some are specific to Hilton, but also I think they're probably, or I should say they're not just specific to Hilton. I think they're probably applicable to many customers. So we wanted to share those. And I think I know Eddie just mentioned this about the parameter groups, right? So you can have a parameter group across different databases or clusters, and so breaking those apart, right? So that is really important, so that one configuration change doesn't affect another, as well as if you do want to test a configuration change, you can isolate that to a specific cluster or instance versus having a sort of a larger collection of those, right? So basically splitting apart your parameter groups. The other thing is using, again, back to monitoring tools, right? So using your monitoring tools to monitor for long-running queries. So this is somewhat dependent on your application, but most transactional database applications or engines, the queries typically run pretty quickly, right? Sometimes in a matter of seconds or even less. So if you have queries that are sort of outside of those windows, things to monitor and keep an eye on, right? So, if you have a query that's running longer than expected, again, monitoring and alerting upon that to take some action. Another one is very specific to Postgres, and actually, in this case, this is a PostgreSQL 10 specific setting in the parameter group. But this is the idle in transaction setting timeout setting. This is something that in the sort of on the default configuration is turned off, but something in the kind of greater, I guess, PostgreSQL community, the order of sort of 10 seconds is commonly used. Again, maybe different for your use case or your application, but something to note and keep in mind. Um, Another one is replication lag, right? So if you're if you have a primary database and then several or many read replicas, for instance, you're going to have a lag, right? You're going to have some sort of the primary is going to replicate that data information to the read replica. So you're going to have some sort of lag there. Typically, it's pretty low, but it's something you definitely want to monitor, right, and keep an eye on. Again, back to alerting. You might find a threshold that makes sense to alert upon, but as well as keeping sort of trend analysis, right? So if you look back weeks or months, whatever it might be, understanding, sort of the peak and valleys of that lag. Is there certain things that happen that affect that, right? Those sorts of things is important. And then one other thing, um, and this is again specific to Postgres, but probably other engines is something called vacuuming, where if you have a table that has a high amount of uh, transactions or activity, I should say, on the table, we recommend sort of turning vacuuming on at a higher rate for those. So uh, again, this is going to be specific to your application, but it's something that you can kind of use guidance as a table that has a higher rate of change. You probably want to vacuum that more often. So with that, Eddie, I will turn it back to you to talk about some of the future plans.
Cool. So, for what's in store next for the Hilton team and the migration after we finish everything out? So, we've been able to have several successful items happen as a result of this. First and foremost, we've been able to reduce early morning maintenance windows with the new application and database tiers. It means we get a little bit more sleep. Part of that is we continue to cost optimize the database tiers as Amazon comes out with new reserved instances and looking at different instances with optimization. And we update our application code to make it more efficient. So just from the application tier, from the cost, all the different types of architecture, we're constantly looking at how to make everything better. And the other part is we're excited to see every new development that comes out with the Aurora family. This moving to Postgres opens the doors to some exciting new database components like RDS proxy and Aurora Global Database.
All right. So Eddie, I guess I'll take it from here, or from both of us, I should say. Appreciate your time and thanks for your interest. Um, and again, thank you.